All right, this is actually our last section, our last master learning objective for Target 1A, and we are looking at our 1A.5 master learning objective. I can simplify an expression, so starting the same way as all our other ones, by using the power rule to raise exponents to an exponent. Okay, so this is just another rule. We've seen product rule, which is multiplying two things, quotient rule, which is dividing. The power rule is taking exponents and raising them to another exponent. Okay? So we're going to start the same way. We're going to kind of figure out these rules by expanding. So x to the third squared. That means I'm going to have, you need a pen, x to the third times x to the third, right? It means I have 2x to the thirds. Now, we remember, right, now I'm just going to use my product rule, right, my base is the same, I'm going to add my exponents. 3 plus 3 is 6, okay? So x to the third squared is x to the sixth. Number 2, 2x squared to the fifth. So I'm going to have 2x squared, 2x squared. I need 5 of them, right? Just like before, I'm going to take all my coefficients out. I have 5 2's. Then I'm just going to add all of my exponents. I have 5 squareds. 2 times 2 times 2 times 2 times 2. You can always use a calculator to help you out, but that is going to give you 32. X to the 2 plus 2 plus 2 plus 2 plus 2 is going to give me 10. Okay. So 32x to the 10th. Number 3, x to the fifth, y to the fourth, all squared. So that's x to the fifth, y to the fourth, times x to the fifth, y to the fourth. Again, since I'm multiplying now, I am adding my exponents. Okay. X to the 10th, y to the 8th. Now I want to look at how can I kind of skip that middle step, right? The expanding part, which sometimes takes a long time to write. Well, if you look, 3 and 2, how do we get to 6? Well, 3 times 2 is 6. 2 and 5 to get to 10. 2 times 5 is 10. 5 times 2 is 10. 4 times 2 is 8. Okay, so when I have this power, an exponent raised to another exponent, I'm just going to multiply them. Okay. My coefficients, just like before, are still just being raised to that power. They don't have the same, the coefficient does not have the same rule as the exponent. Okay. So let's look at examples. All right, again, now I don't know how to expand, I don't know how to write a third of an x to the sixth, right? I can write 3 of them, but I can't write a third of one. So now that we can't expand it, we can use the rule we found. Okay. So again, all I'm doing is forgetting to turn my pen on. X, and then I'm multiplying my exponents, right? So the product rule, when I multiplied, I add my exponents. When I have an exponent, I multiply them. Okay. 6 times 1/3 is simply 2. Easy enough. All right, now, here we have our coefficients, right? So with a coefficient, it just gets raised to that power. Our base and our exponent, right? We multiply them. So the biggest mistake is students will do 25 times 1/2 instead of 2 to the 1/2. So be careful, the coefficient still just gets the exponent. The exponent gets multiplied by the other exponent. Okay. I'm going to use a calculator to tell me what 25 to the 1/2 is. Not that one. this one. So 25. Let me bring this in a little bit so you guys can see all the buttons. This is your power button right here. Okay? You can see that it moves it up just like an exponent, and it's to the 1/2, so just 1 divided by 2. And that gives me 5. 25 to the 1/2 is 5. 4 times 1/2. Again, if you need to, feel free to use 4 times 1/2 is just 1 divided by 2. Okay. And I am given 2 there. Okay. So that is my exponent, 5x squared. All right, let's look at example 3. Y to the 8th to the 1/4. Again, just a nice simple one. I have my base and my exponents, so I am multiplying them. A lot of the same answers here. 8 times 1/4 is y squared. It's not always going to be squared. These just all happen to be. All right, and then example 4, 27a to the 9th to the 1/3. Again, this 27 is my coefficient. All right, so it's a little different. So I'm going to do 27 to the 1/3. And then when I do have a base with an exponent, I need to multiply those two exponents. Okay? So 27, come on, to the 1 divided by 3 is 3. 9 times 1/3. 9 times 1 divided by 3 is 3. So my exponent is 3. So 3a cubed. Okay. All right, go ahead, turn the page. We have a few more problems on the back. 4 more. All right, so this one looks a little crazy. Example 5. I have c to the 12th, to the 1/4, then to the 1/3. Don't be overwhelmed. It's just exponents being raised to exponents being raised to exponents. All I'm doing is multiplying all of those together. So I have c to the 12th times 1/4 times 1/3. Okay. Easy enough. Then I'm going to multiply that in my calculator. 12 times 1 divided by 4 times 1 divided by 3. And I get 1. But remember, we do not write an exponent of 1. So this is just c. So c to the 12th to the 1/4 to the 1/3 is c. Okay, for these last 3, these are a mix of all of our rules now. Okay? So you might have to use your product rule, your quotient rule, 0 exponents, negative exponents, and then the power rule as well. Okay? So looking at example 6, since these are, we're still going to use order of operations, so it starts with parentheses. So I have to do these exponents outside the parentheses first. Okay. So this is just our power rule. -4 to the 3rd. Since it's a negative base, you have to keep parentheses around it. And then x to the 4 times 3. And we get -4 to the 3rd. A negative number. That's a good thing to point out really quickly before I move on. Be very careful. If you're putting in a negative, it's here where this is a minus sign. And I almost forgot my parentheses. So -4 to the 3rd. Okay. And I get -64. Got 6. I don't know why this just, again, decided to jump. So we have 64, negative 64, and then x to the 4 times 3 is, 4 times 3 is 12. Okay. Now I have to do the same thing with the other piece of this, right? So I have 2 squared, and then I have x to the 5 times 2. Okay. So with that we get 2 squared is 4, 5 times 2 is 10. Okay. Now all I'm doing is the product rule, right? I'm now just multiplying. So I have my coefficients, negative 64 times 4, and then I have, these have the same base, so I am adding my exponents. Negative 64, whoops, negative 64 times 4 is negative 256. And then x, 12 plus 10 is 22. Okay. All right, looking at example 7. Same thing here. I'm going to start with my coefficients. I'm raising it to the power. Now I have 3 different bases, so I have to do all 3. So I have x to the 2 times 4, right? Then I have y to the negative 3 times 4. And then I have z to the, remember there's technically a 1 here, 1 times 4. Okay, so that 4 has to go with every single piece of that, in those parentheses. 5 to the 4th, again, you can use a calculator for sake of time. It's 625. 2 times 4 is 8, so x to the 8th. Y is negative 3 times 4, which is negative 12. Z to the 1 times 4 is 4. Okay. Now, if you notice, this y has a negative exponent. I do not like negative exponents. So I'm going to rewrite this, and all I'm going to do is put the y underneath. So I have 625, x to the 8th, z to the 4th. So everything with positive exponents. And then things with negative exponents go on bottom. All right, example 8. This is just a division problem to start with. So 4 over 12. Then looking at my m's, which is the the higher exponent is negative 2 or 2 larger. 2 is larger. Looking at my n's, right, technically there's a 1 on this one. Is 1 or negative 5 larger? 1 is larger because any positive is larger than a negative. And then finally I have the p's. Again, this p has a 1. Which one's larger? 3 is larger. So then, 4 over 12 is 1 over 3. Then n, right, 2 negatives become a positive. 1 plus 5 is 6. P to the 3 minus 1 is 2. M to the 2 minus negative 2 is 4, right? Because I'm adding there. Again, you don't need that 1. Okay. So either of those. All right, that is it. Again, go look at your activity, pick which section you are going to do, and then get that checked when you are done. After this, you will be taking the A mini quiz. Okay, there is a mini quiz since this was the end of the target.